Let's see how to engineer and validate a self-adaptive smart grid. Design the physical model in your preferred modeling tool. Now export the model as functional mock-up unit, which is a standard for model representation. CyPhEF is able to manage any physical model represented via FMU. Now, copy the FMU at the generated location. Open CyPhEF. The tool includes 3 projects. The first contains the meta model and the libraries which allow to design the control architecture. The second contains the dependencies which allows to run a new CyPhEF project. Finally, the third includes the graphical elements which allows the developer to design the self-adaptive system. Now, we are ready to design our self-adaptive smart grid. Launch a new CyPhEF project as an Eclipse application. A new environment, where it will be possible to design and simulate our system, will load. The new project already contains the dependencies which allow to design and simulate the self-adaptive cyber-physical system. Load the FMU by copying it inside the physical model folder. CyPhEF will automatically export the properties of the loaded FMU into the graphical design environment. In the control model folder, it is possible to create a new control diagram for the physical model. Create a new diagram from the pattern diagram view and name it as you prefer. In the new window, it will be possible to use the graphical elements to design the control architecture for our self-adaptive smart grid. From the Properties tab, it is possible to select the type of control pattern you want to adopt from a set of already available patterns. Select Custom Pattern if you want to design a control architecture without specific constraints. For the self-adaptive smart grid example, select the master-slave type. This pattern allows to realize monitoring and adaptations locally at each node, with a central controller planning the adaptation. Insert the master component. As you can see, analysis and planning activities are automatically embedded inside it. Insert one slave. Since we already loaded the physical model, it is now possible to select the physical components to control. Click on the Managed System graphical element in the palette, and select the physical component to control and the relative attributes. As an example, we monitor the voltage level of the bus 3 inside the smart power grid. Now, connect the managing and the managed element. Let's try to validate the control architecture, even though it's not yet complete. Right-click on the white area, select OCL, and click on Validate. Since the design diagram is not compliant to the master-slave control pattern, the validation process is not passed. In the validation console, you can see which are the constraints that are not respected, so you can easily fix them later. Let's validate now a complete master-slave control architecture, with 1 master and 4 slaves. After a successful validation process, it is possible to generate the code for the designed control architecture. Click on the CyPhEF runtime package, and run the Generate Code class. Now, update the project. As you can see, the control classes are generated. Moreover, the physical components will be linked to the designed control components during the simulation. Fill the classes with the concrete behavior of each activity, and you are finally ready to simulate the self-adaptive smart grid. Click on the CyPhEF Mexico package, and run the Simulate class. The physical model and the control model will be co-simulated. You can also observe the monitored attributes of the components that you are controlling in real time. From the CyPhEF team, thank you for your attention.